Good morning, grade 9, my advisory. Okay, let's have the continuation of our topic volcanoes. Okay, let's move now to the other volcanic landforms. Remember that when there are some volcanic activity, there are some formations. Okay, now these formations may be classified and unclassified. Okay, so therefore, there are some classified, okay, volcanic formations pertaining to their forms. Okay, we are actually dealing with their formation, at the same time, the activity that actually happened inside that formation. Okay, let's move now to calderas. The caldera is a volcanic feature formed by a collapsed volcano into itself, meaning to say that the crater itself collapses, okay, and and making it large to form a special form of volcanic crater. It is called as the bathtub volcano. It looks like a bathtub actually, but it is actually huge. Okay, caldera. Okay, Cal caldaria. The other term, it is actually a cooking pot because it looks like a pot. Are large depressions with diameters exceed 1 kilometer and have somewhat circular form. Remember also that these calderas actually has a bigger role pertaining to the pressure exerted by uh, the cores, okay, exerted by the cores because these areas also are the exits of those pressures. Okay, since sure, what do you mean exits by this pressure? Since these are the exits of the pressure, tendency is inside the caldera is somewhat hot or somewhat um warm. Okay, this means that it actually what create a hotter environment or a warmer environment. Calderas are formed by one of the following processes. The collapse, number one, the collapse of the summit of the large composite volcano following an explosive eruption of silica-rich pumice, okay, and ash fragments. Okay, these are crater lake type calderas. Let me check if I have. Yes, this is it. The crater like caldera. Okay, as you can see, it is really huge. And of course, again, the temperature here is quite hot or quite warm. Okay, it depends upon the pressure released. Okay. The second one is the collapse of the top of a shield volcano. This is a top of a composite volcano, a summit of the composite volcano, which which is actually doing an explosive eruption and remove its summit or the large part. Okay. The second one is the collapse of the top of a shield volcano, shield. Okay, caused by a subterranean drainage from the central magma chamber. Okay, one good example is the Hawaiian type caldera. This one. Okay, again the temperature here is quite hot or warm. Okay, the third one is the collapse of a large area caused by discharge of colossal volumes of silica-rich pumice and ash along the ring fractures. This is now the ring fractures. Okay. One good example is the Yellowstone type caldera. This one. Again, the temperature is quite hot. Okay. From warm to hot. Let's move now to flood basalts. Do you have any questions so far? Again, the first is
None.
None.
the collapse of a the collapse of a the collapse of the summit of a composite, just like your Mayon volcano. Okay, if Mayon volcano has an explosive eruption and remove its summit, therefore it will actually create a what? A crater lake. Okay. Next is the collapse of the shield, and of course, the fractures. Okay, the collapse of a large area and the fractures. Okay, let's move now to flood basalts. A flood basalt is a result of giant volcanic explosions that coats large stretches of land or the ocean floor with basalt lava or basaltic lava. Okay, these eruptions do not produce very much ash, of course. Instead, they produce prodigious amount of greenhouse gases. Okay, specifically carbon dioxide. Okay, now remember that carbon dioxide is a greenhouse gas. And of course, if there are a lot of greenhouse gas in the atmosphere, tendency is it traps heat. Okay, flood basalts have occurred on large igneous provinces in prehistory, creating great plateaus. This is how our plateau is actually created, and mountain ranges. These have erupted at random intervals throughout geologic history and have clear evidence and are the clear evidence that the Earth undergoes period of enhanced activity rather than being in a uniform steady state. There is a theory, okay, that states that um that is actually talking about in order for us to in order for us to have a great a great feature, we need also to undergo a great pressure. Okay, again, in order for us to have a great feature, we need to undergo a great pressure. Pressure and feature. Okay. I heard about this simply because um just like diamond, if you're going to look at diamond exposed in a great pressure. But again, it has a great feature. So most probably it everything happens for a reason. Like for this instance, we are actually experiencing this calamity. We're actually experiencing this pandemic situation, but hopefully this will actually form us as a better individual, as a better community. Okay, again, everything happens for a reason. Okay, just like what is happening to Earth. Okay, supposed to be these are the upon checking on the geologic history, okay, Earth is always moving until now, okay, even creating a numerous, um, numerous landforms and numerous, of course, scenery, okay. So these are the movements, a movement of Earth itself, okay. We are just talking about, this is just in the volcano or volcanic activity. There are a lot of movements pertaining to the Earth's creating these landforms. Like for example, the tectonic theory. Okay, if you're going to look at tectonic theory or tectonic until now is still moving. Okay, remember that we are actually a Pangea. Okay, are you familiar with Pangea?
Yes.
Okay, we are a Pangea. Okay, meaning to say that the landforms there, the land is actually connected to each one of the land bridges. Okay, we are actually moving from one land to another without without actually the use of the sea. They're just walking around, transferring from one area to another. And of course, there are a lot of proofs, there are a lot of evidences that they traveled from this area to that area, okay, because of the fossils. Or the plants there is exactly the same with the plants in the other area. So this is actually what? This is actually an evidence that Earth is moving and Earth is evolving for a better Earth. Hopefully, this will give us also an idea. This will give us a clearer view that Earth is doing something for us, and we are doing something for Earth that can harm Earth. Okay, let's move now to the next topic. This is actually a common flood basalt. As you can see, it actually creates a huge amount of gas, carbon dioxide. And of course, this carbon dioxide, take note, can actually harm your lungs. This is very, very harmful when we're talking about toxicity. Are you familiar with toxicity? This is highly toxic. This is the reason why
Yes.
those people living near needs to evacuate. Okay, there is a need to evacuate. Okay, or else again they will be what? They will be harmed with these gases. Let's move now to energy from volcanoes. Apparently, volcanoes, because of the constant pressure and because of heat, we can actually harness energy from them. Okay? Volcanoes produce a wide variety of potential hazards that can lead to destruction of people, wildlife, and property, of course. This is the reason why, again and again, those people living near the volcano, once the volcano is actually having or actually having an eruption, or the um there are some smokes coming over from the craters of this volcano, you need to again move out. Okay, you need to evacuate. While volcanic eruptions are one of the most destructive natural disasters that kill thousands every year, definitely there are a few good benefits from volcanoes, of course. Okay, one of these is the potential of harnessing heat from volcanoes as energy sources. This is the concept of thermodynamics. Are you familiar with thermodynamics? Everybody?
Yes.
Yes.
Okay.
A bit. A bit.
Energy cannot be created nor destroyed. You cannot create energy and you cannot destroy energy, but you can convert it from one form to another. So if this is a great energy, okay, because this is heat energy and chemical energy, okay, you can always convert this to another form of energy, right? Scientifically speaking, the core of Earth is a nuclear reactor generating heat from the breakdown of radioactive elements like uranium, thorium, correct, potassium, and other elements. Very true. Okay. Scientists have been using that heat for decades by drilling deep wells to power turbines. But now researchers have been able to tap into even a greater energy by drilling into volcanoes and exploiting the heat of molten rocks. Researchers show that if current geothermal wells are placed or replaced with new technology, it could probably provide 30% more power than current renewable energy sources. Correct. Because of that advancement of technology also, these can actually what? Give us another 30% of power. Okay? Scientists think that the natural escape of Earth's heat through its surface average only from 0.06 watt per square meter. To make geothermal power practical, some special situation must exist to concentrate the Earth's heat energy in a small area. Okay, underground reservoir of steam or hot water can be funneled into a drill hole, provide this special situation. Geothermal energy is plentiful, meaning many, but geothermal power is not. Okay, temperature increase below the Earth's surface is at rate of 30 degrees Celsius per kilometer in the first 10 kilometers below the surface. Okay, this is now the concept of the geothermal power plant. Okay, the hot water, okay, from the underground powers up the steam engine, which the steam engine now powers up the turbine, and the turbine moves because of the steam engine, because of this the steam coming from the underground, and of course it generates what? Electricity through the generator. Now the generator is actually generating thousands and thousands of wattage or watts. Okay, from the generator, it should actually what? It should actually travel in a transformer. Okay, to convert these thousands of watts into 220 to 230 watts, which is actually our natural consumption at home. And of course, once the water cools down, it will be actually in the cooling tower and injected back to the mainstream. So the cycle repeats again and again. This is actually renewable. Okay, do you have any questions so far? Questions,
None.
questions?
None so
Okay.
far.
What I want you to do now is I want you to go to your LMS. Can you access your LMS?
Yes.
Yes.
Directly to your
Yes.
LMS and answer activity number 1. Okay. Again, I didn't actually put restrictions there in order for you also to do any time of the day, or if you will miss some of those activities. But again, I'll be checking them one by one. All right? Questions?
No more.
Right. I think that'll do it for today, class. Again, thank you for your
Yes, sir.
participation. I am really happy to see you, AJ, Jillian, and Rabi. Hopefully, your other classmates can join. Okay? Hope to see you soon. Take care. Bye-bye.
Bye, sir.
Bye, sir.